Okay, now. So this
Am
is
I
just
here
a
one?
question. So now the thing is under recording. So we are finding the LCM of
I'm not going.
5, 10, and 15. Okay. So just like I said, when you are looking for LCM using the tabular method, like you have 5, you have 10,
And
and
I'm
you have
15.
15, right? So I encourage you to use the prime 10. Okay. I encourage you to use the prime system. So you use 2, 3, 5, 7, 11, 13, and so on, right?
Yes, sir.
Oh,
Yes, sir.
you can't hear anything. What is happening? I'm hearing the feedback from Precious that she cannot hear anything. But everybody on the group, I think you can hear me now.
Yes, sir. Yes.
What's happening? Sorry, I have to attend to him. Sorry.
Okay, sir.
So please don't disconnect. Oh.
Okay, sir. There's two. What would divide 5 and 15? Five and divide 11.
All right. So I said we're going to be making
Ma,
use of these numbers. Okay.
it's yeah, I'm looking at. It's
Who's talk,
not sleeping.
who is talking? Precious.
No,
Precious
it's Mickey.
is what? Who is
But
talking?
my sister.
Your
My
sister.
sister.
Okay, okay. If they want to talk, so that their noise will not be entering our meeting. If anytime you notice they are talking, just mute your mic. Okay, when they finish talking, you put it up. Do you understand?
Okay, sir.
Okay.
Yes, sir.
So, oh, Shabi, you are using a phone. Abby?
Yes.
Okay, if you can just stay a bit away from them, if you know they want to talk. So, do you understand? If you can stay a bit away from them,
Okay,
don't
sir.
disturb them now. It's already late at night, so they should be resting now. So that name of it will Lara and they are at home. So Nimi, now which of this number can do you think we can use to divide here?
Yes, sir.
Which of this number do you think we can use to divide? 2, 3,
5.
eh? What do you say?
5.
Okay, since 2 can go in 10, before you go to
Sir, 5.
before you go to 5, you should use 2 first.
Yes.
Nimi, do you
Sir.
understand?
Yes, sir.
Since 2 can go in 10, before using 5, you should use 2 first. That is in LCM. I didn't mean it is HCF. That is when you can use 5 straight. Because
Yes, sir.
that's the only number that goes in the three of them. Do you understand
Yes,
that?
sir.
Okay, so when you are looking for HCF,
Yes, sir.
then you make use of 5 that can go in the three of them. But now you are looking for LCM. Once you can see one of the smallest prime number that can go in any one of them, you use it. So 2 goes in 10. Because 2 goes in 10, you can still use 2. Nimi, do you get that?
Yes.
So now 2 in 5, it doesn't go, you write 5. 2 in 10, that is 5, right? And
5.
15, it
Yes.
doesn't go, you write 5. So now that 2 cannot go in any one of them again, that is when you can now use 5.
I see.
Nimi, do you understand?
Okay, sir. Yes, sir.
Aha. So that is when you can now use 5. Only
5.
wait.
Mm-hmm.
When you use 5 now, you have, even before 5, you can use 5 yet. Nimi,
Oh, yes.
you can use 5 yet. Michael, we can use
3.
5 yet. We can use 3. Because 3 goes in 15, right?
Yes. Yes, Yes, sir.
Michael, hope you're following.
Yes, sir.
So since 3 goes in 15, then what should we do? We just use 3. So here we're still going to repeat our 5,
5. I repeat the 5 again.
5, and 5, right?
Yes, sir.
So it's now we can now use 5.
Yes.
Since it's the only available one, so we have 1, 1, 1, right? So by the time we want to do our LCM is not going to be what? 2 times 3 times 5. That is this 2 times this 3 times this 5. All right? So
Yes.
with what I'm seeing here,
Yes,
our
sir.
LCM is 30. Nimi, is that understood?
Okay, sir.
Yes, sir.
Sir?
Yes, yes.
So that is question 1. The question 2 I'm having here says, and so I don't know how to help Precious tonight. I don't know. Is she's finding it difficult to connect with us. So the question 2 I'm having here, Nimi, says that find the square of 324. Nimi, do you mean the square or the square root? Nimi?
Sir, this square.
The square. Okay, so
Sir?
we have to find the square of what? Of 324. So what does that mean? They want you to do 324 raised to the power of 2, right? Which is the same thing as
Yes, sir.
324,
Times.
times 324, isn't it?
Yes, sir.
So that's 324 multiplying 324. Okay? So 4 by 4 is
Yes, sir.
16. So that's going to be 6, remaining 1, isn't it? 4 by 2
Yes,
is
sir.
8. 8 plus
Yes, sir.
1, that is 9.
9.
4 by
4
3
times
is 12,
12.
right? So we
Yes, sir.
Yes, sir.
start under this 2. 2 times 4, 8. 2 times 2,
8.
4.
2.
And 2 times 3,
Times
6. Then we start under this third column. 3 times 4, 12. That's 2 remainder 1. 3 times 2,
3 times
6 plus 1, 7. 3 times 3, then we have 9. So when we add up,
9.
Nimi, do you understand that?
Yes, sir.
So here we have 6. Here we have
6,
17.
7. Keep 1.
Yes, we keep 1. Here we have 9,
9.
right?
plus the 1, 9. Yes, sir.
Yes.
6 plus 1 is 9. Then here we have 14. And here should be,
5
14.
4. 10.
isn't it?
10.
So 1, 2, 3. So that's 104,976. Hello, do we understand it?
Yes, sir.
Okay, okay. So that is question 2. Question 3. What's question 3 saying? Question 3 says,
9 raised to the power of 3
9 raised to the power of 3
divided by 9 raised to the power of 3
divided by 9 raised to the power of 3.
to the power of 0.
Oh, to the power of what? Of 0.
0.
Oh, okay. So what is that? They want you to do 9 raised to the power of 3 divided by 9 raised to the power of 3. So when you pick one of the one of the bases, then that's going to be 3 on top. This division will become what?
Yes.
Minus, right?
Minus.
Then
Yes, sir.
the 3 again. So now still raised to the power of 0. They still want you to raise it to the power of 0. So that is what? That's already 9 raised to the power of 0 inside, all over 9 raised to the power of 0 outside. Do you understand what I said? What I'm doing?
Yes, sir.
Hello?
Sir?
Michael, is this still with me?
Yes, sir.
Okay, so what is that answer going to be? 9 raised to the power of 0 itself is 1. Because
Yes.
anything raised to the power of 0 is 1. Then, now raised to
Yes.
the power of 0 again. So 1 raised to the power of 0 is even 1 itself. So our answer is 1. Do you,
Okay, sir.
do you understand that?
Okay, sir.
So question 4. So what do we have in
Yes,
question
sir.
4? Question 4. Michael, please work on What's that now? Work on how to upload your questions. Do you understand?
Okay, sir.
Question 4 now. We have negative indices, right? So,
Yes, sir.
Nimi, that question is not clear. What is there?
And they say I should solve the question negative indices.
Okay,
3 raised to
3
power 4 minus 3 raised to power 6.
raised to the power of 4
Raised to power 4
minus
minus
3 raised to the power of 6, isn't
3
it?
raised to power 6.
Okay. So that's
Yes, sir.
a negative indices. Okay. Now there is what we call factorization. Nimi, there is what we call factorization.
Sir?
People in higher classes will be able to understand it better. So what do we do here? Now you can see 3 raised to the power of 4 common to both. I don't know if you understand.
Yes.
3 raised to the power of 4 is there. 3 raised to the power of 4 is there. By the time you factorize, okay, so 3 raised to the power of 4 is common. Sorry, my writing is breaking. Okay, let me quickly explain what I'm trying to do here, so that what can I do now? Okay, it's like they are saying 8 minus 4, and they want you to factorize. So, Nimi, what is the common factor of 8 and 4?
4.
Good. I love that. 4. So because 4 is common to 8 and 4, then you write in 4, you write 4. So you now say 8 divided by 4. What's that?
8 divided by 4, 2.
2 minus 4 divided by 4 is what?
0.
No, that's 1.
1, 1.
1. Then you close your bracket. So you have factorized this. Nimi, do you understand that?
Okay.
Hmm?
Yes, sir.
Okay. Now, let
Yes,
me
sir.
just do one more example. If you have, what is that? Oh, let's say 18 minus 12. So what's the common factor of 18 and 12?
12.
That can divide 18 and divide 12 without any remainder.
2.
Any higher one? I know 2 is there. 2 is a factor, but do you know of any higher number?
Mm.
Hmm?
Okay.
A highest common factor, that's 6. 6 in 18 is 3, minus 6 in 12 is 2. Nimi, is that
Okay,
clear?
sir. Yes, sir.
So that is the same thing we want to do here. So 3 raised to the power of 4 is here, 3 raised to the power of 4 is also here. So by the time you factorize, you have 3 raised to the power of 4 common. So what is left here? That is, you want to say 3
2
raised to
raised to power
that
6.
is here divided by the factor you brought out. Nimi,
Sir?
3 raised to the power of 4 that is here. I don't
Yes, sir.
Then divided by the factor you brought out, 3 raised to the power of 4. What's your answer?
Yes, sir.
Do you get what I said? Now, see,
Yes, sir.
this 3 raised to the power of 4, 3 raised to the power of 4, then divided by this factor you brought out, this one, 3 raised to the power of 4.
Yes, sir.
Then minus, this minus, you have 3 raised to the power of 6, still divided by this 3 raised to the power of 4 that you brought out. You know, that's what we did here. You divide it by 4, you also divide 4 by 4, this factor. Here, you divide 18 by 6, here you also divide 12 by 6.
Yes, sir.
Do you understand? So because 3 raised to the power of 4 is a factor here, you use 3 raised to the power of
Yes,
4
sir.
to divide 3 raised to the power of 4 here. You also use it to divide 3 raised to the power of 6 here. Nimi, do you understand?
Yes, sir.
So now you're going to be having what? You're going to be having 3 raised to the power of 4 outside the bracket. What do you have left here? If you do this division, 3 raised to the power of 4 divided by 3 raised to the power of 4, what's your answer? Nimi? Nimi, oh. Hey? I hope I'm not disconnected.